So I'm going to go back to my dashboard, create a new circuit. SIK 3.2 Servo example. Go back here. All right, same idea. Introduction at the top of what exactly is happening. Looks like I will be using the breadboard, my Arduino Uno, a servo, and some wires. This is a servo. The big difference between a servo and a motor is that the motor is just going to spin continuously. The servo will only sweep through a certain degree, so it doesn't spin forever. It's more like a windshield wiper. Okay. All right, so to start with, this is all I'm gonna have. It's pretty straightforward. I'm gonna have my Arduino. Here, I'll go down, make one bigger. The power and ground, and the servo also has 3 wires, a power, a ground, and a kind of data, right? And so in this case, this one's gonna go to pin 9. So let's go get that part set up. I'm gonna get my breadboard set up. I'm gonna go find the servo. Looks like I have 2 to choose from. I'm gonna take this one. All right, so this one, power, it's red, ground, black, and signal is going to number 9. I'm gonna make that one yellow. Okay, I'm gonna close this one. All right, I'm gonna now copy the code for this one. Go look at the code section over here, in text, delete what's already there, paste in the code, and we will go see how we're doing. Okay, up at the top, we have a description of the sketch and the circuit that we are making. It has a reminder of the hardware connections and how to hook it up, as well as the website on how to find it. This is an important line. Include the servo library. So Arduino has a lot of cool stuff available to it, but it doesn't like to load every possible available thing into every program, because that would take up a lot of space and your Arduino memory is limited. So an include statement will cues your program that you would like to use this available section of code called a library that has all the commands needed in order for you, in this case, to talk to your servo. If you don't include that library, but you try and use commands from it, it just won't work. It's going to give you an error. So that include section is really important. And then we need to go tell it that we will be using a servo. This is a servo object. Arduino is an object-oriented programming language. I believe there's a page on that in Canvas, or you can Google it. But what this means is that we need to create an instance of this particular device that we're using, in this case, a servo. You'll see this kind of syntax, this setup again in the future. Now that we have created our servo number 1, we need to attach it to pin 9. This is something directly from that servo library, and there are resources on exactly how the library works and what all the commands are on the Arduino website. as well as in the library itself. Right here, you can find a list of the functions in the Servo library at. So this is where I would go if I wanted to see what all of my options were when dealing with a Servo. And every library will have a list, or should have a list of available functions. Okay, in the loop section, we start with a position. Position is going to hold what kind of degree measure the servo is at a given time. First, we're going to servo 1, so that's this servo right here, right. We're going to tell it what to do. 90, so that's 90 degrees, which I believe is kind of straight in the middle. We're going to wait 1 second. We're going to go to 180 degrees, wait 1 second, go all the way to 0, which is the other direction, wait 1 second. Okay, I'm actually going to, for just a second, I'm going to comment out the next part so that we can see just this much run and see how it works. So I'm going to hit start. Okay, so there's 90, 180, and 0, and it's running through those options. 90, 180, 0, 90, 180, 0, 90, 180, 0. So you can see those kind of discrete movements it's making. All right, I'm going to stop that simulation. To slow down the motion and make it move instead of in kind of jerked motions a little more seamlessly, we have this kind of sweep thing set up here. So I'm now going to comment out this top one because you just got to see how that worked. And we're going to do this sweep one instead. So they're doing this with a for loop. If you haven't seen a for loop yet, this is a good time to learn them. There is also an explanation on how for loops work and a couple of examples on our Canvas page under Arduino Programming 2, I believe. It's got some examples of conditionals, different kinds of loops, things like that. So the way this for loop works is it is going to use this index called position. It's going to start at 0 and go until until this is no longer true. So it'll go up by 2 each time. I'm just going to walk through how it will look on the first one. So it'll start at 0. So servo 1 will write 0 to its position. So it'll go to that 0 degrees. It will delay 20 milliseconds, which is not very long, super fast. And so then it will know that it's going to go up by 2. So now position equals 2. 2 is still less than 180, so it will go down and do this again. It will servo 1 right 2. So now it'll be at 2 degrees, delay for 20 milliseconds. It will go up by 2 to 4. 4 is still less than 180, so it will go to 4 degrees, wait for 20 milliseconds. We see how this is going. So this is going to very kind of go 0, 2, 4, 6, 8, 10, 12, right? But it happens so quickly that it will look pretty smooth. At the end of this, position will have reached 180. And because of that, this for loop will stop because if position is 180, it is not less than 180, so it will say, oh, I'm done with this loop. I'm going to stop now. So now this for loop will take over. It will start position at 180, subtract 1 each time instead of add 2, and go until it reaches 0. So it's going to do the same thing as it did up here, but it's going to do it slower because the delay time is the same, but instead of going up by 2 degrees each time, it's going down by 1 degree each time. So it should take twice as long to get back to where we started. So let's take a look. You should be able to see there's the sweep up to 180 and then back down to 0, up to 180, back down to 0, and it does take longer to get back down to 0. All right, I'm gonna stop simulation on that one. Hopefully we understand how both of those two different ways work. So this one was doing very specific, discrete measurements, and this one was sweeping through using a for loop, forward and back. What are the values for current, voltage, and resistance? Can you add an on-off switch? So I'm gonna show you a little bit of that. The reading voltage, resistance, and current doesn't work quite the same on here as it does in class, but we can do at least some of that. So if we go to all components and we scroll down a ways, there we go. There is a multimeter. It just has the positive and negative, and it lets you choose, once you start the simulation, whether you're trying to read current, voltage, or resistance. So let's go ahead and read pin 9 maybe? Sure. And let's see what we get. So you can see it's on voltage right now, and it's reading from pin 9, or sharing the signal from pin 9 to ground. And so you can see the voltage change as it moves. Pretty much all there is to it. Okay, I'm gonna delete that guy because the thing that I would like you to more learn from this one is how to add components of your own and changing the code. So we're gonna add an on-off switch. So let's go find an on-off switch. I think I'll do the slide switch, and I'll put it over here. So this slide switch has 3 poles: terminal 1, common, and terminal 2. And if we think back to how we set up a button, we're gonna set this up the same way as we would a button. Don't know if you remember how we set up a button, so let's go look. Oh, you know what I can do is I can look on here. Push buttons. So if you think back to buttons, buttons have these 2 legs that we're gonna kind of work with. And one is just gonna go straight to ground. And the other is gonna go through a 10K resistor to power and back to the board. So that's what I'm going to do here as well. So one leg is gonna go just to ground. I'm gonna make that one black. And the other leg is going to need a resistor to go to power. This one is already, let's see, 10K, there we go. Except that's in the wrong place. There we go. It's going to this center leg, that's the common one. So we need a pair of these, the middle one and one side. We could do either side, but this is the way that I chose first. So that's what we're gonna do. And so this center leg goes through the 10K resistor to ground, and I'm also gonna take it to the board. It's close by, I'll use number 12. So now I'm gonna go back to the code and add some stuff. So first I'm going to go up to the header section and alter it because I'm now altering the program. It is the 5th based on Sparkfun Inventor's Kit Sketch 8. I'm going to delete all the explanation, but leave the credit for who wrote it. Now that I understand how this thing works, I'm going to maybe also delete a whole bunch of some of these comments because it's going to make it easier to see what my program is doing. Okay, it's a little better. So I might want to keep track of what pin my switch was connected to. So switch pin 12. This is constant, so I can label it as such, but you don't really have to. You can leave it as an integer if you like. I'm going to set up the pin mode. Again, this is just kind of good habits to be in. Switch pin has an input. Okay, and what do I want to do? So the first thing maybe I want to do is I want to use my serial monitor, which I didn't set up yet. Hold on. In my setup section, I need to let it know that I would like to use the serial monitor by telling it serial.begin. And what I'm going to print out is I'm going to digital read. If you don't remember if it should be digital analog, read or write, I think that was last week's video. Look at that. I talked a whole lot about how to choose which one it is. In this case, a switch is either on or off, so that's digital, and I am looking to get information, so that's read. So digital read, switch pin, and I'm just gonna send that to the serial monitor and see what I'm getting and make sure that I have it hooked up correctly before I do anything else. So I'm gonna start the simulation. And currently it read it once and then is doing this sweep thing before it reads it again. So right now it's reading at 0. If I click it, and we wait for it to come back around to that part of the code, we get a 1. Okay, so kind of 0 on this side, 1 on the other side. So it's gonna start at 0. Stop my simulation. Okay, so I like the sweep better, so I'm gonna go ahead and delete kind of all of that non-sweep stuff. And I have to decide what I want my switch to do. But it's gonna be an if statement. So if the digital read on the switch pin is 1. Oh, okay, I'll just have it turn the whole thing on or off. That's what I'm gonna do. So here we go. If digital read switch pin is 1, so I just said that that was when I clicked it over this way. So when that reads 1, the double equal is checking to see if it is 1, not assigning it to 1, checking to see if it is 1. And if it is 1, I will do this sweep. If it's not, I won't. All right, let's see how it goes. Okay. click, hey, and it does the sweep. And because it is still a 1, it will keep sweeping. If I turn it off, it's going to finish the cycle it was on and then stop. So one thing I did is I did not make this a print line so I could read it easier. I'm going to do that and go again. All right, so it's reading 0. When I turn it to 1, does that once. And then when I turn it off, it will finish the cycle it's on and stop. All right. So that would have completed driving a servo motor as well. So we learned a little bit about reading values using that multimeter, and then we added an on-off switch to control the servo by changing the code. That's a pretty complete 2 sets of projects, so I'm going to stop there. Hopefully this is what you're working on this week, and then we are going to work on Arduino project 2 is our next up. All right, everybody have a great day, and email me if you've got questions.